Good morning, everyone. Today we are going to continue with chapter number 5, Web Server, from the subject Web Frameworks. In last sessions, we have seen about how to create web server, what is web server, then the web application architecture. In web application architecture, we have seen that it is divided into 4 layers. First one is client, then server, business layer, and data layer. In client layer, we have seen that the client may be a mobile browser, web browser, or any other application. Then in server, web server takes the request from that client and process that request. While processing that request, it connects with the business layer. Business layer consists of application server and file system. That application server may be connected to that data layer with the database and with the external system. These are the 4 layers of web application architectures. We have seen that client layer, server, and business and data layer. Then we have seen how to create the Node.js web server. While creating the Node.js web server, it makes easy to create a simple web server that processes incoming requests asynchronously. Here you can see the one example how to create a Node server or Node.js web server. Here see this example server.js file. We have declared one variable HTTP, and by using that require function, we are importing Node.js core module, that is HTTP, by using require function. We have taken another variable using var server equals to http dot create server. Create server is the method from that http module, and in that we have written one function consisting of request and response, and we are going to creating a server and handling incoming requests. And at last we have written server dot listen in bracket 5000. This is the server is listening this port number in that is incoming request, and at last we are going to print that Node.js web server is running at port number 5000. Okay, this is the simple example of creating Node.js web server. Then how to run this, we have seen that write Node.js node and file name, that is server.js. It will show that message we have written in console.log, that is Node.js web server at port 5000 is running. This is how we can create a Node.js web server using simple steps. Okay, now we'll see how to handle that HTTP request and response. Here for handling that HTTP request, the HTTP create server method is there. HTTP dot create server method from the HTTP core module. It includes request and response. It includes the request and response as the parameters which is supplied by Node.js. The request object can be used to get information about current HTTP request. This request object is used for getting the information about current HTTP request, for example, URL, request header, and the data. And then response object can be used for to send a response for the current HTTP request. Response is for sending the response to that current HTTP request. Here there is one example that how to handle or how to handle that HTTP request and response in Node.js. Here you can see we have taken one variable HTTP and we are importing Node.js core module by using require function HTTP. Then we have written one variable as server, and by using that create server method from that HTTP core module like http.create server, we have written inside function with the parameter request and response, and now we are going to create a web server. How? Here if request.url equals to slash, that means here we are going to check the URL of current request. Here we are going to check the current request and we are going to set the response header. How? Here request, for that request we are going to set the response header by using response parameter of the create server method. Response, that is res dot write head in bracket 200 comma content type as a text or HTML. Then we are going to set the response content to that header like response dot write. In the inside that we are going to write that HTML code, that is HTML body, then paragraph, that is This is home page, and we are going to end that HTML code here. And at last we are going to end that response like response dot end. Else if we are going to check it's for another page, that is request dot url equals to in double quote slash student. For that page we are going to write that response header, and we are going to set that content here. Like similarly we have written for that current request, and we are going to write for another request here, response dot write head 200 content type text slash html. Then we are going to write the content for that response content. We are going to set here by using res dot write. We are going to write that html code, that is we are going to print the message as this is the student page, and we are going to end that response. Else if we are going to check that it is for another page, that is the request dot url equals to admin. Similarly we have to write a response header for that, and we have to write set response content for that and end that response. Otherwise we have to print as like else res dot end invalid request. At last we are going to write server dot listen in the bracket 5000. This is the port number. That means it's listen for, server will be listen for that incoming request. And at last we are going to print console.log Node.js Web Server at port 5000 here. This the port number is running. Okay, this is the example of how we are going to handle or that HTTP request and response here. Here in this example we have said that request.url, here request.url is used for to check the URL of the current request, and based on that it sends the response. To send a response, first it sets the response header using write head method and writes a string as a response body using write method. Here we have set the response header, and we have write the content using write method. Okay, and at last web server sends the response using end method here. By using end method we have sent the response here. How to run this? Like node then file name. Here you can see after running this file it will show that Node.js Web Server at port 5000 is running. It will print this message. And if we are running this on the Windows, for Windows user at web browser write http slash double colon localhost colon 5000. This is the port number, and this will show that current http request. Here it will show this page. This is the by default current request, so it will print this is the home page. Here you can see this is the home page. And similarly it will return for the student. If we write like http colon double slash localhost colon 5000 slash student, then it will print as, open the page as this is the student page here, that now url is student, okay, slash student. So it will print like that this is the student page. Similarly it will, if we write like admin instead of student, if we write here admin, then it will show like this is the admin page. Okay, either it will show that invalid page. The next point is Node.js streams. So what are the streams here? Streams are one of the fundamental concepts that power Node.js applications. They are a way to handle reading, writing files, network communications, or any kind of end-to-end information exchange in an efficient way using the streams. Streams are not a concept unique to Node.js. They were introduced in the Unix operating system decades ago, and programs can interact with each other passing streams through the pipe operator. In Unix, we have seen or we have learned that by using the pipe operator, we are executing multiple commands or multiple operations using that pipe operator. Similarly, we are using this concept as a stream in Node.js. So for example, in traditional way, when you tell the program to read a file, the file is read into memory from start to finish, and then you process it. First, we will read that file completely, and we are going to process after that reading. But using streams, you read it piece by piece. Whenever we are going to use streams, it will read that file piece by piece, processing its content without keeping it all in memory. We are not going to keep all that content of that file in the memory, because we are going to read that file in piece by piece. Okay, so that Node.js stream module provides the foundation upon which all streaming APIs are built. All stream APIs are instances of event emitter. Here, why streams are necessary? Here, streams basically provide two major advantages using other data handling methods. Here, two advantages are memory efficiency and time efficiency. In memory efficiency, you don't need to load large amount of data in memory before you are able to process it. If you are not able to process it, you cannot uh, take that data or load that data into that memory. So that is memory efficiency. This is the advantage of using streaming. Then another is time efficiency. It takes less time to start processing data as soon as you have it, rather than waiting till the whole data payload is available to start. So it is time consuming. It will take less time to process that data. Then here you can see this example of streaming. This is a typical example, that is reading files from disk. Here, using that Node.js FS module, that is file system module, you can read a file and serve it over HTTP when a new connection is established to your HTTP server. Here, this is the example of a stream. Here you can see the example of stream. Here, one constant HTTP is equals to require function will import that HTTP module here. Then another constant FS, it will import that FS module, that is file system module. Then another constant here server, for using that methods of that HTTP module. Here equals to constant server equals to HTTP dot create server. Inside we have written one function having parameter request and response. Inside that we have written the method of FS module, that is fs dot read file. Here read file method from FS module. Inside that we are going to read that file name and the data of that file. Here you can see the directory name plus we are going to read that complete file here, data.txt. Okay, then if is there any error, it will return that error, otherwise it will read that file. And at last response dot end data. And at last we are going to listen that server, that is we are going to listen that incoming request at the port 3000. Here, read file reads the full contents of the file and invokes the callback function when it's done. Here, read file will read the complete file and invoke the callback function. And that response.end here, response.end data. In the callback, it will return the file contents to the HTTP client. Using this, it will return the contents of that file. If the file is big, the operation will take quite a bit time of. It will take some time if that file is big for reading. Okay, here you can see, so we are writing stream for that. How to write stream? Here constant HTTP equals to require function is for importing module. We are importing HTTP module. Similarly, we are going to import that FS module here. Then another constant we are taking as a server, like constant server equals to using create server method of that HTTP module. How to use that? HTTP dot create server. Inside the bracket we are going to pass the parameter request and response. And now here you can see inside the bracket we are taking one constant stream equals to fs dot create stream. Fs dot create stream. This method is from FS module stream create read stream, and we are going to read that stream, that is that file name here, directory name plus data.txt. This is a text file we are going to read as a stream. Here stream.pipe in bracket response here. And at last we are going to listen that incoming request here at the port 3000. Then instead of waiting until the file is fully read, we start the streaming using this it to the HTTP client as soon as we have a chunk of data ready to be sent. Here you can see we have written a create read stream function here from the fs module to read that file as a stream. Yeah, there are different types of streams are there. There are four classes of streams: readable, writable, duplex, and transform. Here, readable streams are it a stream you can pipe from but not pipe into. That means you can receive the data but not send data to it. Okay, it means you can read the data but you cannot send the data to it. When you push data into a readable stream, it is buffered until a consumer start to read the data. It is buffer until consumer start to read the data. Whenever consumer start to read the data, it will be readable. Either it will be buffer into that memory. That is readable stream. Okay, then next one is writable. A stream you can pipe into but not pipe from. That means you can send the data but you not receive data from it. Okay, writable means you can send the data to server but you cannot receive from it. That is writable stream. And duplex stream means a stream you can both pipe into and pipe from. That means basically a combination of readable and writable. That is duplex. And transform stream is, it is similar to duplex but output is a transform of its input. It is a transformation of its input. These are the four types of streams. And next one is, this is the last point from the chapter number 5, that is HTTP streaming. Here, what is HTTP streaming? It is a push style data transfer technique that allows a web server to continuously send data to a client over a single HTTP connection that remains open indefinitely. It is a simple, or it is a push style data transfer technique that allows a web server to continuously send data to a client. Here in HTTP streaming, a web server continuously sending data to a client over a single HTTP connection that remains open. Technically, this goes against that HTTP convention, but in HTTP streaming, it is an efficient method to transform all kinds of dynamic or otherwise streamable data between the server and client without reinventing HTTP. Whenever we are going to request any data from that web server, after sending the request, it will continuously send the data for a single request in, that is HTTP streaming. Then how that HTTP streaming works? With that HTTP streaming, the server is configured to hold onto a specific request from client. Whenever customer or whenever client is requesting for that server, it will hold onto that specific request from the client and keep the response open so that it can push data through it. When updates pertaining to the request are available at server side, then server sends a response through the request and response channel, and only close the connection when explicitly told to do so. When the client want to end that connection, after that it will end that connection, otherwise it will continue with that pushing the data through it, with that channel, request and response channel. In such a manner, a client can listen for the updates from the server and receive them instantly with none of the overhead associated with HTTP headers and opening and closing of the connection. It also eliminates the need of for polling. And how the that HTTP streaming works here. Yet to achieve this, to achieve an indefinite response from that server, it must respond to client request by specifying transfer encoding, that is chunk in the header. Transfer encoding chunk in that header. This sets up the persistent connection from server to client and allows the server to send response data in a chunks of new line delimited strings. These chunks of data can be received and processed on the fly by the client. Yet HTTP streaming works like, whenever user sends the request to that server will respond with the request and response channel and sends the data to that client simultaneously. This is how HTTP streaming works here. Or alternatively, the data may be streamed via server sent events, that is SSE method, for which there is a standardized HTML5 API called event source. With that SSE, data is encoded as text event stream in the header. It sends the data in the form of streams, that is piece by piece. It will continuously send the responses to the request of that server or request of that client. This is how HTTP streaming works here. Thank you. In this way, we have finished the chapter number 5. Thank you.